Hello! In lesson 8.3, we are adding and subtracting polynomials. So, we've talked about this before, the concept of having like terms. Like terms will always have the same base and always have the same exponent. So, for example, we might have 2a squared and 4a squared. Notice, same base, same exponent. Okay. When adding and subtracting polynomials, you add or subtract the coefficients. The fact that we're adding or subtracting does not change the overall variable. Think of it in terms of apples and oranges. If I have 2 apples and I add 7 apples, I don't have suddenly becoming something else like an orange. It's still going to be apples. We're going to have 9 apples. So if I have 2a squareds and 4a squareds, when I add them together, I'm now going to have 6a squareds. So some of the things I like to do when I'm adding polynomials is first I remove the parentheses and rewrite each term. And then I combine only like terms. Again, they have to have the same base and same exponent. Or they might be like terms in that they're both constant terms. They have no variable attached. So let's look at some examples. Here's our first example. (12m squared plus 4 added to 8m squared plus 5. So again, the first thing I would do is rewrite without my parentheses. Okay. So I rewrite it, 12m squared plus 4, 8m squared plus 5. Now we can only combine like terms. Constants with constants, m squareds with m squareds. So you can see I underlined the m squared terms. 12m squared, 8m squared. They will add together to give me 20, and it stays m squared. So I write that down. 4 and 5, those are both constant terms, and so when I add those two, I get 20m squared plus 9. Let's look at our next example. So again, we have two polynomials. 6x s squared plus 3s plus 7 added to 2s cubed minus 6x s minus 4. So again, I start by rewriting. And again, you can see I've kind of already underlined this with similar markings, like terms. So we have s cubed. There's no term like the s cubed, so I write it down. All right, so I have 2s cubed. S squared, there's no other s squared, so I write it down, s squared. 3s, take away 6s, those are like terms. 3 take away 6 gives me negative 3, so I have negative 3s. Then I have my constant terms, 7 and negative 4. 7 take away 4 leaves me with 3, and we get our answer. Okay. Now, our next one's a big one, and you're going to see I have a lot of writing here, so let's take a look at this more carefully. So here you can see we've got two trinomials, but we have a coefficient in front that we have to multiply. We have to distribute into the binomial, or trinomial in this case. So I have to take 5 times every single term in the parentheses. So I'm going to do 5 times 2x squared, 5 times negative 3x, 5 times 10. Then I have to do the same thing with my second trinomial, but this time with the number 3. 3 times 3x squared, 3 times 2x, and 3 times negative 10. So we multiply, and we get 10x squared minus 15x plus 50. That's from my first expansion of the trinomial. Second trinomial expands to give me 9x squared plus 6x minus 30. Again, we have to combine like terms. So you'll see that we have x squareds underline, that gives me a total of 9. So I have 19 x squared. It's a 10x and a 9x squared. Then I combine my x terms. A negative 15x and a positive 6x will give me a negative 9x. Then we have our constant terms. 50 and negative 30 we subtract, and that gives me a positive 20. Okay. So now let's talk about how to subtract polynomials. First thing I do is very similar, but the first thing I'm going to do is distribute the negative as a negative 1. Think of it as a negative 1 in front of my trinomial or binomial. Then, once we do that, it's exactly like the previous questions. So let's look at our first example. All right. So in our first example for letter A, you can see that we have a negative in front of my trinomial of 5x squared plus 2x minus 2. So again, I want to think of that as a negative 1. So we're going to rewrite the first trinomial the way it's written, but then our second trinomial, we're going to multiply every single term by negative 1. So let's see what we get. So you can see I rewrote the first trinomial, but now for the second part, negative 1 times 5x cubed gives me negative 5x cubed. Negative 1 times 2x squared gives me negative 2x squared. And negative 1 times negative 2 gives me positive 2. Again, we need to combine like terms. So we combine a 2x cubed and a negative 5x cubed to give me a negative 3x cubed. 4x squared and negative 2x squared gives me a positive 2x squared. Negative 6 plus 2 gives me negative 4. Let's look at our next example. Again, distribute that negative 1. All right, I wrote the 1 in. If there isn't a 1, you can always write a 1 in. So again, we rewrite the first trinomial as is written, but it's my second trinomial that we multiply by negative 1. So we get negative 3c cubed plus c minus 1. And again, we combine like terms. So we have an 8c to the 4th. There's no other term to combine with it. Negative 3c squared, again, no term to combine with it. 2c and 1c gives me a total of 3c's. And 3 minus 1 gives me 2. Now, the last thing we're going to look at is a little bit of really more of an example of vocabulary. All right. If I subtract 2x cubed plus 9y to the 4th from 10x cubed minus 6y squared plus 10, what's that really telling me to do? Is it saying write the 2x cubed plus 9y squared first? Or is it telling me to write the 5x cubed minus 6y squared plus 10 first? Let's think of an example. If I subtract 10 years from my age, do I say 10 minus 43? Or do I say my age 43 and subtract 10? It's the latter. It's the latter example. So this is the same idea. So I have to take my 5x cubed minus 6y squared plus 10, write that first, and then write 2x cubed plus 9y squared second. So that's the first thing I did. Once we establish that, now the problem is exactly like what we did. Remember, this is like having a negative 1 in front. So I have to distribute negative 1 into my binomial. So the first trinomial gets written the way it is. Second binomial, we have a negative 1 that distributes into it. So let's see what we get. So I copy my trinomial. Negative 1 times 2x cubed, negative 2x cubed. Negative 1 times positive 9y squared becomes negative 9y squared. Then it's just a matter of combining like terms. My cubed terms get combined, to give me a 3x cubed. My y squared terms get combined to give me negative 15y squared. My constant term, there's nothing to combine with it, so it stays the same. And our fourth example is the same idea. Again, the second one goes first, and the first one goes last. Then we distribute our negative 1, and we combine like terms.